Okay, now we're going to start with actual statistical procedures that require hypotheses testing. The first thing I want you to do is go into the folder that's called Analyses and Outputs and click on that folder. What you'll see is 3 files. The first one that I want you to open is called Means Comparisons. And what you'll see is at the very top, you'll see t-test. So we're going to talk about t-test. And t-test assumptions include several things. The first thing is that you have an interval or ratio as your measurement, a test score, for example. Second, the scores in your population are normally distributed. And third, that the variances, which are simply your standard deviation squared, are equal. That's called homogeneity or equality of variance. In reality, those 3 assumptions don't really matter. They technically need to be in existence, but in practice, when they're not, they really won't affect your results. Sometimes when you don't meet an assumption, your results are just totally invalid. In the case of t-test, that's not true. But you should know what those assumptions are. So the first thing that I want to emphasize again, this is how the course is outlined. You have output 6, and I'm telling you the test is a 1-sample t-test. And what you're going to do with a 1-sample t-test is you're going to compare the mean of one variable with something that's known for the entire population. So again, a good example of this might be, this isn't true, but people believe that the average IQ for everyone in the country is 100. I want to know if the mean IQ for students in this class is different than that 100. So back to my little flow chart, my little logic model. Does the mean IQ for the people in this class differ than the known value of 100? So I ask myself, how many variables do I have? I have 1, IQ. How many groups do I have? I have 1, the students in this class. That tells me it's a 1-sample t-test. So that's a little bit about a 1-sample t-test. Then I'm going to give you a specific problem. And I'm going to say, in this case, does the mean number of students taught by each teacher on a daily basis differ from 100? And what you'll see is exactly what you need to click on in SPSS to run that test. So let's do that first. The database that's relevant here will be Teacher 2. So we can walk through this together. Analyze. I know I'm in causal comparative for the reasons I just explained. 1 variable, 1 group. I know I'm running a 1-sample t-test. So I need to scroll down and I need to find the variable. What's the number of students? Total number of students. You can see how far down I had to go. Total number of students that a teacher works with each day. And I drag that over. And I want to know, does that mean differ from a value of 100? The known national average, if you will. So I type that in and I click OK. And when I go to my output file, that's what I have. The results of my 1-sample t-test. 1,498 teachers answered the question. Their average number of total students in a day was 96.24 students. The standard deviation was 142. I got a significance of 0.308. That's above 0.05. So there's no difference between 96.24 and 100.